Alright, another Chapter 2 question. Or not Chapter 2, Problem 2 question. And so remember the issue here is here we have our pressure drop equation. Where we're given delta P, we know LD and rho. What we don't know is velocity. Alright, so looking at this equation, it might appear as if I have two unknowns, F and V. Okay, but then if I were to look at the Kohlberg equation, which we use to solve for F, okay, so this equation has F, relative roughness, I know epsilon and D, and Reynolds number present in it. Okay, Reynolds number is rho v d over mu. I know rho, I know d, and I know mu. The only unknown is v. Right, so F is essentially just a function of v. So if I look back up at this equation, then the only unknown I really have is v. Okay, and so I'm going to have to set up an error function, which is, say, our pressure drop, which we're given, minus our pressure drop as we calculate it using this equation. And then F0 will keep iterating on v until it finds dv so that equation is satisfied. For each v that it guesses, I can then send that v to, say, my Kohlberg solver to solve for, or calculate Reynolds number, and then solve for F with that guess value of V, and then keep iterating until I have a solution. Okay, so let's see what we have. So the code as I received it is such. Okay, so first thing I'm going to do in terms of helping me troubleshoot this is I see I've got this function with L rho PD. I'm guessing that's my roughness and mu as inputs. I'm going to create a script, okay, just so I can call this animal. Okay. And so it has something like v is equal to that. Then above it, I'm just going to define them so that every time I want to run it, I don't have to define those parameters. Okay, so L is, and I'll check the units once I get them in there. Okay, L is 0.2. Okay, that is meters. Rho, our density, is 1.23 kilograms per meters cubed. P. Okay, so again, my convention would be I would tend to use a lowercase p to indicate that it's a scalar, not a vector. Save capitals for vector quantities. So this is 50. That'd be kilopascals. Okay, so I might label this as, say, P underscore kPa is 50. So P underscore pascals is 50. Well, is pressure in kilopascals times 1e3. Okay. Again, I'm just going to get all these in there. I'll worry about the units and figure it out. It's just as I test this, I don't want to have to keep entering these every time. D, my diameter is 4 millimeters. Okay. So D in meters then would be D in millimeters times 1e3. 1e negative 3. EP, I'll take that to be my pipe roughness. And let's just pick, say, 0.26 for now. Mu, my viscosity, is 1.79 e to the negative 5. Okay, and I think I'm just going to leave it at that. Newton seconds per meter squared. Those are some good units. SI units. Alright. Oh. Okay, so I need to save this animal, and let's just call this, I don't know, vcaller. Okay, so this is just a script to call that function, so all I have to do is run it, and it runs. Okay, but then let's look at it and see what we actually have. Okay, so I pass all this information to it. Then I have a pressure drop anonymous function I'm creating, which has an input of just V. Okay, that's good. V is what I'm trying to solve for. And P drop solve takes as inputs F, L, rho, V, D, and P. Okay, so the first thing that stands out to me is if this is going to be my error function, in which I'm solving for V, F can't be there, right? And you see F is underlined because F isn't, defined in the function workspace yet. It's unknown. Okay. Now, if I were to trace things and look at p-drop solver, which is this, we have F times L times 1/2 rho v squared over d minus p. Okay, so that is this equation rearranged. F times L over d. Yeah, so that's got a correct error function here. Okay, so that's good. Okay, only input or issue again is going to be this F, right? F is unknown in addition to v, and so we'll need to figure out this F business. Okay, and let's just look at the rest of their code. So that'd be them solving for v, and then they have this Colebrook solver up here, where once they solve for v, then they're going to attempt to solve for f like they did in the last problem. But it really doesn't make sense, right? Because f is a function of v, and I need that here. Okay, so what I suspect we need is just a little rearranging. So I'm going to delete f as an input there, f is an input here, because f is just a function of v. And then what we need to add is, now that I have v, right, I can just solve for f, and it looks like this is going to be my ticket to do just that. Okay, so I'm going to define a Colebrook anonymous function, which will have an input of f, and it'll call cf, okay, with that value of f along with ep, d, rho, v, and mu. Okay, so then the inputs here, the information I need to pass is, let's see what's unknown. Let's see if highlighting can help me. Okay, ep, okay, d, rho, v's there, mu's not, right? So it's going to be mu that I need. Okay, I'll need mu as an input as well. So then up here, I'm going to need ep and mu, so that I have the same number of variables in the same order, right? I'm passing and putting them in the same correct places. So then this will pass that information to CF. CF is my Colebrook equation, F, EP, D, rho, V, mu. I'll solve for my friction factor. Then once I have my friction factor, with that guess value V again, I can calculate my pressure drop and compare that to the pressure drop we're given. So that looks good. Okay, you have a Reynolds function. That looks good. Looks good and fine. Looks good. Okay, so now before we test it out, let's just try and... here, then this isn't going to be res. Alright, res is velocity. Okay, so now if I peek at my expressions here, I'm just going to try and quickly look at units. So F times L times 1/2 rho V squared D minus P. So if I were to just make sure all of those were in SI units, then I know my velocity would be in meters per second. And so that EP and D just need to have the same units here, right? So let's just put everything in SI. Looks like we're using the same D throughout. So EP, okay, this is say in millimeters is that. So EP in meters would be EP in millimeters times 1e to the -3. Bam! So then I'm going to call it as L, which is in SI, rho is SI, P. So now I want P in pascals, D in meters, epsilon P in meters, and mu is already in SI. Okay, boom. Okay, now moment of truth before we run this is I give some reference values. So when epsilon is 0.26, I get a velocity of 141.1115. Okay, so moment of truth. So I just need to run vcaller. 141.1115. Right? Cool. Okay. So this guy appears to work. Nice. Okay. Now the one thing you could in theory do is let's let's ramp this up even more. So maybe instead of vColor then, let's make it turn into a function with an input of epsilon, which is the variable I'm trying to change. Okay, so it works. Okay, so now I'm going to update it. I'm going to do function res is, and I'll call this vColor, and we're going to have input of epsilon p in millimeters. We'll let the user specify the relative roughness in millimeters. Okay, so that velocity will be what I want to return. I'm going to do res for that. Okay, now epsilon in millimeters. Okay, I can comment out that row or essentially delete it because that's now a user input. So now I call vColor. So I'll do, say, v. If I want to assign the velocity to it, v is vColor. Should press the output there. V is vColor, and let's do 0.26 millimeters. 141.115. Drawn tubing was 0.0015. How many zeros? 0.0015. Bam, 281.00668. Success. All right? And then if you wanted to, what you could do is, if you want to package them all up in once that's working, I could just paste that, say, on top here. Boom. Okay. Well, I would need to rename this. Well, okay, so what I should probably do is I can copy all of this. I don't need the comments at the bottom, right? But if I were to say copy all of that, right here I copy and paste, right? If you were, say, programming from the command line, Vim, there's simple :R, and you can insert the contents of a file. Okay, but now in this updated code, everything's packaged together, so you could just email out that single M file, and it's all there. Okay, cool. That was fun.